Welcome. I'm Iryna. I did marketing at Quilter, and I will be moderating the webinar today. And I have Sergiy and Richard with me who will actually run through the presentation. I will do a proper introduction just in a minute here. A few housekeeping items. The webinar is recorded. We will share the recording shortly afterwards. And second, please feel free to ask questions and leave comments throughout the webinar in the chat window to your right. We will run through the slides first because we have a lot of material to cover today, but we will make sure to answer all your questions at the end during the Q&A. And if we don't get to your question live, we will definitely get back to you via email. So please ask away. We're very happy to engage. So now proper introduction of our hosts. So Sergiy is our founder and CEO. After years at SpaceX, he founded Quilter because he realized how much of a bottleneck PCB layout can be for a hardware project. And Richard is our VP of product. He has decades of experience leading software teams and product teams in the tech industry. And I think many of you guys might have met Sergiy and Richard in some capacity because there's some familiar faces on the line. Now, what we will cover today. First, we will do a short overview of what Quilter is and what it does. As I mentioned, we see some familiar faces on the line, but there are also a lot of people who we haven't met yet. So we want to make sure we're all on the same page and everyone has somewhat of an understanding of what Quilter is. Then we will cover key themes of our product updates this year. Richard will cover these. Then we will show you a preview of our roadmap and what's coming soon. And we should have plenty of time for the Q&A. And now I will pass the mic over to Sergiy.
Okay, thank you, Iryna. Thank you, everyone, for joining. So first, we'll go over a bit of what Quilter's all about. And fundamentally, the reason we're here is from a pain I felt when I started the company, but also a pain that I talk to people about every day and our customers, which is just that the pace of hardware is accelerating drastically. We speak to folks all over the hardware industry, from electrification to defense, robotics, into space, and there's tidal waves of demand pushing all of these forward. And the capacity for PCB design and PCB layout is not keeping up or scaling with that demand, quite simply. We speak with companies who are focused on electrification of vehicles. Of course, that demands a whole lot of hardware design for the actual power systems, but also the testing systems to qualify vehicles to be safe on the road. And that drives a whole lot of PCB demand. We see demand in defense, both the kind of prime defense companies and the neo-primes and the companies that are following the wake and the startups are shifting over to drones as the kind of the war in Ukraine has taught us, shifting over to autonomous operations and more advanced sensors, radars, phased arrays, and that's driving a lot of demand across that industry. We're seeing the development of robotics and humanoid robotics in particular, where you have to have a sensor and an actuator in every fingertip, every joint, every area. And that drives not only the creation of hundreds of PCBs throughout a robot, but also flex PCBs around the joints, which is a whole new demand that's coming up. And of course, space, where we now have tens of thousands of satellites in orbit compared to a fraction of that from before. And again, those are just flying PCBs in a sense, I'll say. Next slide, please. What we're seeing pretty consistently is that layout in particular becomes a bottleneck across all of these companies and across all of these industries. And it's not necessarily just that quite simply doing a layout in a perfect world is itself this time-consuming thing. It's this realization that we're hearing from companies across the board that layout plugs into dozens of different teams that have to contribute to the product. So when we start a layout, obviously we get mechanical constraints from the mechanical team. We get sometimes a partially completed schematic from the electrical engineers. We get some choices of parts that might still be swapping. And every time we make a bit of progress here in this flow, the requirements change, or some review needs to happen, or a stack-up negotiation has to happen with a fab or a vendor, or a material's out of stock and we have to redesign. And every time one of those changes comes up, you end up re-triggering or respawning some 1 or 2 or 3 week sub-process of now we need a new floor plan, or now we need a slightly better placement, or we need to swap out a part, or whatever it might be. And when you stack the labor of layout and how important it is to get it right, with all of those inputs coming from thousands of different directions to PCB designers, you end up in this process that, practically speaking, for many boards that we're seeing, takes 4, 6, 8 weeks, all the way up to 20 weeks in some cases. And so obviously, as we're alluding to, layout becomes this bottleneck that we see an opportunity to try to alleviate. And so the purpose of Quilter in general is to try to help hardware companies by compressing these individual steps as much as we can, so that the whole organization can ship a PCB more quickly up to its standards and requirements. So what we see from companies all across the world and all across different industries is that every company has its own process for what a PCB design looks like. Sometimes if it's a startup, experienced engineers just know and don't necessarily write it down. But at bigger companies, it's usually pretty well described in a formal process where there's individual gates, reviews, stakeholders who have to sign off. And what we've done here is try to simplify it and just present a common form of what we see to give us one single frame for discussing this. So generally, we see that the first set of problems that get addressed are just simply the design request, like what is the board, why do we need it, what are the resources to design it, so on and so forth, and the constraints around how it's going to be manufactured. So that is the Stackup, the constraints definition around the board, what materials we're allowed to use, and so on and so forth. Typically, this process takes a couple of weeks. Of course, this depends very much on the board, but it is an important area to start grabbing a whole lot of stakeholder inputs. This typically moves into initially a floor planning phase, where the general question of roughly where do our subcircuits go, and is that floor plan going to allow us to close timing, to close power distribution, and other key concerns, maybe skylining concerns. And typically that also gates at a review before we move into fine placement. And so floor planning might be a week, detailed placement might be another week, even on a simple board. Of course, from there, we move into routing, where typically companies start with the most important routes, high speed, SerDes, differential pairs, DDR, so on and so forth. That typically hands off with a signal and power integrity team for a bunch of cycles. And then there's some general cleanup routing of GPIO and less critical signals before this gets handed off into DFM, where other teams might even come in and provide their expertise around what is going to be the most manufacturable design before releasing to a final design and to a release. And as we've mentioned, adding up all of these steps tends to equate to 4 to 8 weeks, even for a medium complexity board, but upwards of 20 or more weeks for the really complicated boards of the industry. So this is where we focus our efforts, in particular on these middle sections, starting from how do you define your Stackup and what the constraints for the design are, all the way up through the early DFM, DFA, and simulation sign-offs. We provide a set of tools to try to accelerate those pieces. So to state it very plainly, what we've observed as we work with customers is that for the kinds of boards that are most in demand, there is no single button automation that just completes all of this, and nor do we claim to deliver that. What we're actually doing is we're providing an assortment of tools to make each piece go a lot faster. But the key point is that the team that is driving the work has to stay in control, has to understand what's happening with the design, has to understand what's happening with the tool, and try to compress these individual sections. One of the analogies we sometimes take is to the progression of self-driving cars in the industry. A self-driving car is an easy concept to explain, but it took multiple decades to get there. And in reality, first we had cruise control or lane keep assist or auto park or those other pieces before we started to get a Waymo that can take me across San Francisco. Quilter is approaching this in much the same way. And we're very much in the world of cruise control and lane keep assist and not Waymo. And so all of the features that we'll touch on a bit later, you should treat as individual pieces that can help take the burden off from you so you can focus on the harder pieces. In particular, there's two major sections that Quilter focuses on, and that is placement and routing segments. And from here, by automating some of the floor planning discovery and placement work, and by automating the initial sketch routing, we can help you better define what a Stackup that is suitable might be and what the constraints for the board need to be. And we do that by, since we can automate those pieces, you can quickly experiment. So you can quickly, for example, take Quilter through what would this board look like in 6, 8, or 10 layers and get a quick result. You can quickly play with different floor plans Do we want high speed on the right or on the left? Do we want analog on the right or on the left? And get quick results. And that is meant to inform your design process to commit to higher quality results sooner without taking all the time to vet them. Next slide, please. The way that this works is that you start in your existing ECAD system as you normally would. So if you work in Cadence or Altium or Xpedition, your schematic stays there and your initial constraints and footprints come from there. So you start with a general board outline, locations of fixed components such as mounting holes, and then you take those CAD files and give them to Quilter. Quilter will then assemble further design context. For example, what stackup are we targeting, which can come from your design files or from predefined manufacturer standards. What constraints we want to hit in terms, of course, manufacturing constraints, such as the smallest traces we want to allow via aspect ratios, separation to board boundary, things of that nature. But even more importantly, the intent of the circuit. This is critical information that's generally missing from CAD files, but that we try to reconstruct, which is what is actually happening on all of the nets and all of the critical signals throughout the board, and what does that imply for the correct layout for those pieces. Right? We can't help you with a layout unless we understand the schematic and unless we create a layout that suits that schematic. That's very important in a design context. The Quilter engine then is fundamentally a constraint optimization solver. So to be very clear, we are not using large language models or anything of that nature to try to create layouts. Anybody who has asked ChatGPT nicely to create a layout will have had some nice giggles about that. Instead, we view this as a problem where you can enumerate the quantitative criteria for what a well-functioning board is, and then try to solve for the creation of the geometries that satisfy that criteria. And that kind of optimizer loop, which we approach as a reinforcement learning problem, is the way we believe how this problem should be solved. This iteration on design candidates that try to satisfy the criteria presents multiple candidate options. So we present multiple placement and multiple routing options, which then you bring back into your CAD system and you iterate with. And so there's fundamentally two loops that we encourage users to take. One is within Quilter, what are the constraints we're pursuing, and Quilter itself trying to optimize. And one is a higher loop with you, the user in the loop, where you see a better strategy than Quilter has taken, and you change your inputs, change your floor plan, change your constraints, and send Quilter for another optimization run. And that ultimately leads to a design review where Quilter checks as many things as it can check about the quality of your design. We try to focus on being agnostic to the CAD systems we work with in order to accommodate the teams that we work with. So we support Altium, Cadence, KiCad, and Siemens, Xpedition, and we try to support those natively. So to be clear, Altium and KiCad are already very well supported, and Xpedition and Cadence are in beta stages at this point and getting to a pretty good state of polish. But we work directly with those CAD files so that you don't have to learn any new CAD system, and nor do you have to install any new plugins or interchange formats. The burden of understanding these files and writing back to these files is fully on us. We also support multiple deployment options. For teams whose security allows it, you can simply use our cloud, where you don't need to do any software installations, just bring your CAD files, drop them in, and we'll take care of the rest. But of course, in many industries, that's not acceptable. And so we fully support self-hosted versions where Quilter can run on your company's servers, which is suitable for ITAR, security clearances, all sorts of very information-restricted settings. With that, I'll hand this over to Richard, who can take us through some of the updates over the last 6 months or so.
Great. Thank you. Appreciate it, Sergiy. All right, let's get to it. All right, there we go. So one of the themes we've been pursuing is to allow you to hand off more of your work to Quilter. One of the things that we've seen in the past is that you need to do a little bit of pre-work. And so we're trying to pull more of that in so you don't need to do as much prep. So one of the ones that is clearly a blocker for a lot of projects is BGA Fanout. All of these high density boards that really take a lot of time to route, and therefore, which are places where Quilter provides the most value, have BGAs. So we introduced automated BGA fanouts a little while ago. We've got pretty good coverage now, actually, like fairly high density, high pin count, a bunch of different form factors, and that runs automatically when you kick off a job. You tell us which ones you want fanned out, which ones you don't, It happens as part of the flow, and we route from there. So we also started pulling in clearance constraints from your files. So your design rules come directly from your ECAD. You don't have to try to reproduce them in Quilter, which we were otherwise asking you to do. We currently have support for Altium Constraint Manager, and we are actively expanding that, particularly to Xpedition and Allegro. The support for Altium is quite good now, and we'll show you a preview of which ones we detected, so you can confirm that's right, make any changes you need to back in your rules if you want to, and then when you push it through, our router and our placer will respect all those rules. So we had pre-calculated impedance profiles. So if you had 80 ohm or 100 ohm impedances, we had those pre-calculated, and we could use them for stackups that we already knew about, the internal stackups that we were supporting. What we've done now is to actually integrate Simbeor into our flow. So between one setup page and the next, we calculate what the trace width and gaps will need to be for each of your different differential pairs, and single-ended impedance too. And so you can just freely enter whatever impedance you need and on whatever stackup you have, and we'll calculate it for you. Importantly, if you already have these pre-calculated, you can override ours. So we'll calculate, and then you're welcome to go in and enter your own if you disagree or if you've got some specific requirement. So we're really looking to support whatever flow you need. So this is an interesting one. One of the comprehensions we have, comprehensions are really the way that you and Quilter talk to each other and establish an understanding of what your intent is. We have comprehensions for things like bypass capacitors, which we automatically detect. And one of the things we do is we try to place it really close to whatever parent pin it's supposed to be bypassing. One thing that we didn't have previously was a way for you to just go in and tweak specific other components that we didn't have a pre-existing comprehension for. This one we use for lots of things. TVS diodes is really one of our go-to examples. Any kind of protection circuitry, there's just such a diversity of them, and we aren't going to support all of that just automatically yet. And so for this, if you've got TVS diodes, for instance, you can tell us which pin you want it close to bypass. You can tell us how close you need it to be, and really force Quilter to do whatever it is that you actually require in your design. Yeah, and so we also started supporting Cadence schematics natively. Previously, we were going through an export script process that was a little bit burdensome. There were like extra steps there, and so we're trying to really remove all of the barriers to use. So we were supporting Cadence binaries, the native file formats for boards before, but we've added schematic support. And schematics, as you of course know, are really the source of truth for a lot of things. So us being able to analyze the schematics gives us much better understanding of what components should be clustered, better detection on things like bypass capacitors, better just understanding of your circuits in general. And that's our dependence on schematics is going to increase in the future as we add some more features. Oh, yeah. So the other thing that we're trying to do is make sure that Quilter isn't a magic box to you. We want you to really see inside, understand what's going on, and have access to all of the levers that we can give you access to. So if you, for instance, want to use Quilter to do something that we don't support yet, but you can see some combination of controls there. For instance, rigid flex PCBs, we don't officially support, but you have enough insight through the tool now that we've seen customers do them quite successfully. Gotta get the next slide. We'll see what features we're talking about here. The setup flow. Previously, it was very heavily automated with not a lot of visibility into things like, as you see here, the Stackup. So we're now showing you everything that we're detecting out of the Stackup, letting you modify those things, letting you choose different Stackups there, and modify things like the copper class, like what the layer type is. So signal, power, ground, you can modify it current, like in Quilter, instead of needing to go back out to your ECAD tool and change some things and come back in. You can also modify the design rules. So if you like just the general overall fab minimums, let's say. So things like via size, and I think we're getting to that on the next slide. So I won't talk about it completely yet, but it's a couple of slides down. Let's go back a slide. I'll talk about the overall flow a little bit more. We've broken out a couple of other sections too. So we have some comprehensions, which are what we understand from you, making sure we've got a shared perspective of what's in this design. And then we've split off these computed ones. So things like the impedance calculations we're talking about are a thing where you give us some input, we do some work on it, and we show you our work and let you override that. So it doesn't happen without you being able to check it. The same is true for trace widths on calculated power nets. So you tell us how much current is going to pass through a net. We'll calculate the appropriate trace widths for heating on the exterior and interior layers. But then you can also go in and fix that if you want. We're just giving you a lot more access to how Quilter works. That said, if you click next, mostly it'll still work fine. And so you don't need to get into the weeds if you don't want to, but you can if you're interested. Next slide. Yeah, so this is what we were talking about before with the differential pair impedances. Yeah, you've got a high degree of control now. You tell us what you need, and we'll make sure to calculate the right numbers for you. Yeah, ground net control is an interesting one. We have combined a couple of things here. One is that you tell us what your primary ground net is. We've got pretty good detection on that. I trust it almost all of the time. But if you have an interesting design where we aren't getting the right principal ground, which is what we assign to the ground planes, then you can change that. The other thing that's been pulled in here is what we're calling region ground pores. You might also reasonably call them split ground planes. We're making it so that you can do them, but we're very explicit about them. They're never going to happen automatically. You're never going to end up with a split ground plane if you don't really want it. The way that's working is that if you put a region or a room on the board, and there are components that all share a ground, like an earth ground or something within that group, then if you click the checkbox for region ground pore, we will give you a separate ground plane there for them. So you get good isolation. Yeah, so this is the thing I alluded to earlier. So in addition to being able to edit all of these, what I really think of as being like fab minimums, what's your real minimum trace width? What's your real minimum trace clearance? And we do make sure that your other rules don't violate that. So your fabricator will be happy. One of the things we've added is this visual review of them. So this is not just floating in space, it's actually right next to your board. And so you'll see the relative size of the numbers that you're choosing. And if you modify things like board margin, then you'll actually see what that inset is. And that's just really useful. We have observed some mistakes in the past, typically where people think they're in one set of units and they're in a different one. But this makes it obvious right away that you've made a trace that's massively too large, or that you're like going to create a problem. One of the other things on here is that if you look closely, you can see at the top of that list, there is a unit selection. So you can be in millimeters, micrometers, or mils, and we respect that throughout the app. So change it one place, we'll stick with it. You can just use whatever units you're used to, whatever units you work in. So this is one of our new pages. This one's quite early. I think of it almost as a placeholder, but floor planning is such an important part of board design that we wanted to make sure that you actually took a look at it and understood what Quilter was intending to do. So from things like rooms to components that are on the board or off the board, and a few other combinations of things, we really walk you through what's going to happen. You can check a few things. We have a couple of other tests built into here. For instance, if you left a bunch of vias on the board, we'll call that out because Quilter won't move any vias that you left on the board. And we want to make sure that you really meant for those to be there instead of putting a bunch of obstacles in our way. The other thing you can control here is how much component clearance you're going to have. Quilter is very good at packing components in very tightly. And so it is very easy to make a board that will be hard to route. And so this is one of those places where you've got a little drop down. You can tell us, you can even type in a different value. The other thing that we've added here slightly more recently is that we will give you a suggested component clearance. And that's what we think is most likely to give you success, whether or not it fits on the board with all that extra buffer. Next slide, please. Oh, real quick. Sorry. Floor planning is also going to be expanding in the near future. We have a bunch of other features coming in here that are going to take this from being a sanity check into being a very active and interactive part of your setup process. We have a lot of internal research. We do lots of research on placement and routing strategies, and generally we don't show them to you. We wait until something gets to a state that we're really happy with, and then we surface it, and that becomes the primary placement algorithm or routing algorithm. What we're starting to do is show you some of those early results because we've seen some very promising things. And so if you see a placement or a candidate with a little beta tag next to it, that means that came from one of our test strategies. Those may not respect all of the comprehensions you gave us. They may not respect everything that you told us about, but they also may be better. They may be better than what we could previously do because they're completely novel. And so we're getting some very interesting results, and those are going to show up a lot more often. And we've got some great plans there. Next slide, please. Yeah, this is going to be really fun. I like this part. We'll just dive into it because I think I figured that was the first one. So projects. Previously, we were just giving you a flat list of jobs. So you'd start a job and run it, and you'd have them all mixed up together. Particularly for someone like me who's testing a lot of things, that is very noisy. It is hard to track all of those through. So what we've done here is to collect all of your jobs that are similar into these projects. That we're enforcing that any jobs in a project be similar. So you can't accidentally mix them up, but it's also because projects are the way that we are metering now, that we are billing for things. So iterate as much as you want within the bounds of that project. So plus or minus 10% on a few different parameters we're checking, and you can explore, you can run any different stackups you want, try a bunch of different design rules, try different placements. We see some number of iterations depending on the complexity of the board and the user's familiarity with Quilter before they find a successful outcome. But all of those are just the same price as the project. So you don't have any pressure to get it right on the first one, and you don't have any pressure to accept something that you don't quite like yet. The projects are just a really nice addition there. Next slide. Yeah, one of the other things we're trying to make more visible is when there's a problem. So we know all kinds of things about what went wrong. Some of them are things that you can fix, and some of them are things that we may need to fix, but we're trying to surface things that you can solve on your own. So for instance, a common error that we run into is when things don't all fit on the board. This happens particularly when you have something like a Wi-Fi module with an integrated antenna on the carrier, because if you haven't pre-placed it on the board, which if you do, we'll leave it alone. If you haven't pre-placed it, Quilter thinks that entire boundary needs to fit within your board area. And inevitably, those antennas are just big, and it takes up a bunch of real estate, and we just can't cram it in. And so we're starting to give warnings like this, which are expandable from the bottom. We've got a little collapsed console that highlights if there's an error. We'll tell you what we think went wrong and how we think you can probably fix it. Next slide. Yeah, one of the common requests was making it easier to look at which nets didn't successfully route. Quilter isn't always going to get to 100%, particularly on complex boards. Like above 95% is quite good in our current state. And so it's nice to be able to go through and actually see which pairs of pins didn't get connected. We were previously showing you just the air wires, and this is just a much nicer way of going through. You can click the little focus and viewer link. We'll pop it right up on your screen. You can see if that's something that's easy to fix or hard to fix, and think about whether that's something that you want to address or whether you want to run Quilter through again with different settings. Next slide. This one I like a lot and use a lot. It is such a minor addition. In concept, this is basically being able to put post-it notes on your jobs and projects. But in practice, we saw, and you can see my screenshot at the bottom with copy, because I duplicate jobs over and over again when I'm testing things. One of the things that I do and that we saw customers doing is really overloading that name field. So you'd be trying a different Stackup, or you'd be trying thinner traces on a job, and you'd end up writing that into the name just so you could keep track of what your experiments were. And then you end up with these just ludicrously long names, and it's silly. And so we made a box. You click the notes, you write down whatever you're changing or whether you thought that job went particularly well or not. The other nice aspect here is that it allows us to communicate with you. So for instance, if I'm reviewing a job from a customer, I can leave notes for them in that little note sticky, and they can write back to me, and that makes support a lot easier too. Also, if I see a job that hasn't gone well and I make some changes and I launch it again, which will also show up in your project list, then you may see a note from me that says, hey, I changed these things. I saw this problem in the setup. I usually sign my notes. But the other thing is that even if I don't, it'll tell you at the bottom of that note who modified it last. So you'll see my email if it was me. Next slide. Yeah, this was a big one that we did towards the beginning of the year. We went from a small reviewer screen, a small preview of the board, to everything is board preview, and there's little menus laid over the top of it, because we know where the center of your focus needs to be. We know where the screen real estate needs to go. And now we're all focused on that one place. The other thing you'll notice along the right side, if you haven't used Quilter recently or at all, we run a lot of design checks. So for those comprehensions that you told us at the beginning, we check all of them, and we'll give you a report card. We'll tell you which went well, which went poorly. You can actually look through the individual checks and see what the values were. We'll let you jump to that section in the viewer so you can see why that happened potentially. And then on the left side, you've got typical kind of layer navigation. And then down at the bottom is the list of candidates that we provided, because Quilter doesn't return just one candidate, except under specific circumstances. Mostly we return several. And so you can look through, see what the results were, see if you like any of them more than another, and then maybe put it in a note, maybe rate it so that you can keep track of them, and then figure out what do you want to do on the next run, or whether this is actually one that you like well enough. One other quick note is that in the lower right-hand corner, which is where you can download your completed boards, we've also added this placement only button. So if you dislike the placement part of it and you want to manually rework it, make some changes, but from here as a starting point, that button gets you exactly what you want. You'll download just the placement in your native ECAD format. You can move things around, modify stuff, and then upload it back to Quilter to route it. All right, I will hand it back to Sergiy.
All right, thank you, Richard. So at a high level, there's a few things that we're focusing on for the immediate kind of 3 to 6 months. The first kind of segment here coming up in this year is going to be focused on placement driven by datasheets. So we're working on the ability to actually point an LLM at the schematic and at the datasheet to automatically configure much of the kind of circuit comprehension that we discuss, to save you the time of configuring it yourself. And that will be informed by, of course, both what's in your schematic and what is in your datasheet. And that should lead to much more nice initial placements without nearly as much user setup time and user rework time. Because, of course, if it takes as long to configure all the constraints for a job as it is to do it manually, then it loses its purpose. So that's something that we're starting to roll out. The next section is regarding power floor planning. So this is something that's actually going to ship here quite soon, hopefully within a week or two or so. And this will take your power planes on all of the power layers that you've defined and properly segment them into the individual voltages that support individual rooms. So if you have an area that requires 3 volts and a separate area requiring 5 and a separate area requiring 12, or even a BGA that requires multiple voltages, this will allow you to create multiple nice big split polygons in one plane to support all of them, rather than what we do today, which is very simplistic, which is just to fill the entire power plane with one net, which is really only suitable for very simple boards. Now, both of those are supporting our general vision of, as we move to helping customers with more and more complex boards, one of the most important areas we get asked for help with is in the initial floor planning. So even if we can reduce the idea of, I've got 100 subcircuits, roughly where do they go, and give you a course placement for that, from a week to a day, a lot of companies tell us that is very valuable. And so a lot of these features are centered around that idea of how do we quickly figure out what are the sub-circuits that matter? How do we quickly get the rules for them? How do we quickly place them? And then give you some idea of what the critical routing and the critical power distribution looks like for that floor plan. And for more complex boards, that's something where we can help with that early setup piece rather than doing the whole thing end to end. Looking at next year, we are going to be continuing to focus on high-speed design, and in particular, adding critical features such as blind and buried vias, which is probably the single most loud request that we hear from customers, is supporting those for all sorts of designs. Supplementing that will enable control of which kind of critical nets or buses or impedance controls you want to run on precisely which layer. For now, Quilter just is free to choose any signal layer at once, but for a lot of more complex boards, the user wants to retain that control. And so that is something that will ship soon. And then finally, length matching for high-speed buses, for DDR, so on and so forth, where we are factoring in, of course, not just the raw length of the trace, but all of the timing introduced by the impedance on different layers, but also via delays. And so that's kind of the big main blocker for us now, is using our internal solvers to compute time delay, which we already do on a plane, but also via delay, which will then allow us to properly do length matching. A little teaser for a feature that we currently have in beta. So this is something that you can go try now and see, is we're starting to focus on quantifying the quality of power distribution. And the first simplest thing we thought to do was basically DCIR analysis. And so this is our kind of first solver serving the question of effectively what is just the DC voltage drop across a net from some given source to multiple sink pins. So when you run Quilter now, when you designate a net as a power carrying net and you specify the current that it's carrying, you will get this kind of report that effectively shows you over the copper that either you've created yourself or that we've generated what that actually is. And this is a pretty quick calculation to do. And so it's pretty trivial to specify this for all the power nuts on your board. And especially once we couple this with the power distribution on a given layer, the kind of nice segmented power pores on a given layer, we think that kind of gets us into the first step of PDN analysis, obviously with AC following later on, but at least DC starting to get there now. We'll also likely re-express this not just as a voltage drop, but as a raw resistance between two values, as we've had multiple customers ask us for being able to set a resistance target between a source and a sink and optimizing the planes until we hit that. All right, with that, I think we can move on to questions.
Yes, thank you, everyone. Let's see. We have quite a few questions. All right, will interpair crosstalk also be considered?
Yeah, Yannick, that's a good question. So to be very clear, as of right now, we do not consider interpair crosstalk, but we are working on being able to calculate that sort of thing here pretty soon. So the kind of solvers that we use under the hood, to be clear for those who are interested, one of the solvers we've integrated under the hood is Simbeor, which supports all sorts of SIMPI type calculations, and crosstalk is definitely one of them. And so we will probably focus on S parameters or signal integrity across a given trace first. That's my guess. And then after that, move into proper crosstalk analysis. But at the very least, as we improve our clearance constraint systems, you should soon be able to express at least something basic like the 3 widths rule between two traces. So if you have multiple differential pairs and they should respect the 3 widths rule between each other, that's something that should be expressible through our constraint system already, even short of a proper crosstalk analysis. But it's definitely on our minds, despite it not being there yet.
Right. Let's actually see. I think folks been voting for the questions as well. So let's start from the top voted ones. Okay. I often work with a 169-pin BGA at 0.5 millimeter pitch on 12 or 14 layer boards, which typically needs 4-6 routing layers for escape fan out. Can Quilter handle that many routing layers for a board this dense?
All right, Richard, don't let me hog everything. If you feel strongly about answering one, feel free to.
I'll jump in. If you want me to. Yeah, I believe we do. I don't believe that our BGA fanout is limited in any particular way until some fairly high extreme where you start running out of memory.
Yeah, I'm pretty sure we've tested it to well over 1,000 pins by now in terms of just least stress testing. And that obviously requires quite a few more layers than that. So that should be well within scope.
Great. Okay, next one by number of votes. And folks, if you see a question that you upvoted, and it will move up on the list. All right, so I could see in the slide, Quilter has routed few tracks under passive parts like caps and resistors. Can the tool avoid this?
Yeah, Ravi, there's generally in any constraint optimization system, there's two ways to express something that shouldn't happen. One is to punish it in the reward, and the other is to prohibit it as a hard constraint. What we see a lot of our users do is directly in their footprints for their passives like capacitors and resistors, a lot of companies actually have a standard of drawing a keep out right between those two pins to make it prohibited to route between them. And then, of course, we support keep outs, and so that'll be a hard constraint that we'll respect. Of course, the downside of that is on a particularly dense board, we might not solve the routing because maybe that makes the routing a little harder. And frankly, in all designs, somebody eventually cheats a little bit somewhere and routes between those pins, even if it's not desirable. And so that is a bit of a choice. We would like to make it more available to the user to control how much punishment there is to go between those pins, but that's not something that's exposed. But prohibiting it entirely by virtue of a keep out inside of the footprint is totally supported, and a lot of users do that.
Right, next question. When I want to add extra vias for either power or ground, like 2 vias per trace for the coupling caps, can Quilter handle this easily?
Not yet. It is on a roadmap, though. It's one of the things that we've got a project around. Also for power handling in general. You're going between two pores and you need a bunch of stitching vias. Yeah, it is one of the things that we're planning to implement.
Yeah, 100%. To add to that, the only place we currently do via stitching is between ground planes. So if we have a couple of ground planes or ground pores, then we'll stitch those at some regular interval. But as Richard said, yeah, it's a good request and something we're excited to implement, but it's not there yet.
Yep.
I'm going to go to a few questions that were asked earlier in the webinar, just so that we're kind of fair to everyone. Which Xpedition format you need as input? Is that full design project with project files linked to PCB?
Yeah, I'll take that one. Thank you, Bogdan. What we generally do is Xpedition stores a lot of its information across a lot of different files. I'm personally not an expert in exactly which one is where. Our team obviously put that together and we can dig into the details if helpful. But the path we've chosen to take is just to ask the user to zip the entire project and upload the zip. And in that case, all of the project file, the PCB file, and all of the supporting kind of like library and netlist and every other file is there. And then during parsing, we go fetch whatever we need from whichever of those files. So I don't have an exact answer for you for specifically which extensions we check. I just know that it's a lot of them. And therefore, we ask you to zip the whole project.
All right. Can you tell Quilter to route first this track and then that one, giving priority to routing strategy?
No, you cannot currently explicitly tell Quilter to do that. However, we do route your critical signals first, giving them priority, and we kind of go down the list. Hopefully that is the same order that you would want them done in, but we're not exposing that yet. We may not expose it in the future, in part because that is one of the kinds of strategies that we experiment with on the back end. And so I'm not sure that we want to let you change those levers so much just yet. But yeah, I was going to say one thing you can do, though, is anything that you want to manually route, you are welcome to do so. You can go and route stuff that you really care about, give us the rest of the work to do, and we'll respect what you've already done.
All right. How the power consumption from each chips is accounted here, voltage power drop?
Yeah, Yannick, the best thing to do with any of our results or simulations is we always provide a little information icon on which you can click and get the full assumptions that were made for that simulation, right? So we always try to be very explicit about what tool we're running, what the inputs were, how we set it up, so that you can analyze whether or not the assumptions we've made match the assumptions that you would be making. The specific screenshot we showed has a very simple assumption of we have one power source, some voltage provider, FET or something like that, and then multiple sinks. And whatever the total current on that net is distributed evenly amongst those sinks. Now, obviously, that's not totally accurate. And it's something that we eventually want to extend in the future so that you can either yourself provide, or we can automatically detect what the true power draw is of each sink, and that changes the kind of voltage drop map slightly because of that, right? The other thing that we're going to do is do a simpler calculation where we just simply take the raw resistance between the source pin and the multiple load pins so that you can get that value independently and study that value. But the main point here is for anything that we present, we should be showing the full set of inputs, assumptions, simulations that went into it, so you can validate if those assumptions match what is actually true in your schematic.
All right. I tried to use Quilter for connecting BGA arrays, but it was not successful. Did you improve the performance, or is it still a challenging problem in automated routing?
Yeah, we've improved it a few times. It depends on when you did it last. You're certainly welcome to send me an email or send support an email. We'd love to see a job where it's having trouble, because anytime you run into something, it's great for us. We'll add it to our testing batteries. We'll figure out what's going on. We're always curious to see places where things fail.
All right. Does Quilter have any notion of loop area, e.g. in SMP designs? Will the datasheet-based placement and routing announced help in this regard?
Generally, yes. So the only overloaded term, the only place in which we track an area, a loop area, is in our switching converter placement. So there we track what is the supply component, what is the inductor, and the full loop area of that whole path, and of course minimizing that. But outside of that, that's it, right? So for example, a loop area of something else, like a critical signal, we don't track the full return path, and so we're not reporting on the loop area. Now, to be clear, the way we get around this now is we are very strict about all of your ground planes being totally continuous with no routing on them in any case ever. And so by that rule, if you're at DC, then your return is just a straight line. If you're at AC, it's right under your trace, but it's basically ideal. But on the kind of top layer with components, the only loop area we track is the switching converter. But of course, we plan to add more and more of that over time, without a doubt.
Okay, Sergiy, directly to you. I'm deeply against when you're still using the term lens matching, which is technically misleading. It should be delay matching. A question: how does BGA outer routers differ from Altium's built-in BGA Fanout tool?
Yeah, Robbie, it's a great point, and I agree. You're right. You're right that it's not that the length needs to be the same, it's that the timing delay needs to be the same. Because if the length is the same in multiple different layers, the timing is different. And so I agree with that, and you're right, I should stop using that term. But the good news is that at Quilter, we do understand that, and we are actually tracking the delay matching. And so I'm just using a poor term for what is fundamentally a feature that understands that nuance. Now, how is this different than Altium's BGA Fanout? Now, our BGA Fanout might be very similar to Altium's, right? This idea that you can take a BGA, click a button, and get something that routes to dog bones and then escapes, probably similar to what's in Altium. But what we then come with is everything else, right? So we will be able to do your placement, your floor planning, your fan out in the loop, and then the rest of the routing according to all of these rules. And it's really the integration of all of these features that makes Quilter an interesting tool, right? All the way up through the final analysis of how well the design did. And that would be my answer to that question, is that fan out for fan out, you'll have to just compare the two tools and see which one you prefer. But the point of Quilter is to stitch together a bunch of these automations and get you an insight into how your fan outs and how your signal integrity plays, even when you're still just studying the floor plan or just studying the Stackup.
I think, okay, we got a few more. Is Flex PCB supported?
Can we take it? Yeah. Officially, no. Unofficially, I've seen really good results. People are using component keepouts and some other things in order to define the flex regions. Yeah, like I said, really surprisingly good results. I was very happy to see that. We are looking at flex in the future, but there are a bunch of changes we need to make. I've got a document going with all the changes we'll need to make.
All right, and one more from Yannick. Can you provide mechanical constraints, heights of PCB?
Yeah, Yannick, the answer to that is so. There's not a mechanism in Quilter to take in like a CAD shape that explicitly shows what the skylining is around those different parts, or DXF or anything like that. The way that we handle it with teams is through the floor plan. So ultimately, you end up creating rooms And in some of those rooms, you end up with tall components. And in some of those rooms, you end up with not tall components. And so typically, in most cases that we see, the enclosure has one region where you expect to have, I don't know, bulk capacitors or something like that are really tall. And then elsewhere, it's smaller. And so you end up with, put my power in this section and all my tall components go there. And then like my digital section can go on the right where there's not as much height. But at the end of the day, that constraint is just expressed by what are the room assignments of like the different components to the different polygons that'll be on the board. You may then have to draw the tall room in only the tall section of where your mechanical allows it. And then like Quilter do the rest of the floor plan. And that's it. So it's an indirect constraint with the same purpose.
Right. Let's see. How is Quilter best used today? Where do you see the most success?
Yeah, I think that's defined by exclusion in a particular way. So we don't do high voltage, or at least we're not officially doing high voltage. We're not doing extremely high current. RF boards, we actually do pretty well if you route the RF sections yourself. But most things, honestly, we're doing pretty well now. I'm feeling pretty good about it. We used to tell people that simple boards weren't a place to use Quilter because the setup time took up so much of what you were saving. Increasingly, I'm seeing that trade-off go away too. Our setup time is decreasing. So even simple boards, less than 100 components, are becoming a pretty smart place to use Quilter. I'm seeing really nice results there. Really high density, I discourage people from using Quilter with because we're working on it, but we're not packing things in as tightly as a human can. In part because, as Sergiy mentioned earlier, if you give us a rule, we follow that rule. And humans, particularly when they're really trying to pack stuff in, tend to fudge a little bit and do a lot of push and shove and a lot of other tweaks that we aren't doing yet. And so we're not going to hit human density on those really packed in boards. And so I wouldn't use it for that. Before anything where you've got a little bit more space, it's pretty good.
All right. Okay, I think we've answered all of the questions in the Q&A. Let's see if we have anything in the chat. Okay, Bogdan, we have answered the question. Yeah, okay, I think we answered all the questions in the chat. All right, then if there are no other questions, we're right on time. Thank you very much, everyone. I'll look out for the recording and reach back to us if you have any further questions. We're very happy to answer anything offline. Thank you for your time.
Great. Thanks, everyone.
Thank you all.
Bye.